In this video we are going to see how to use and create a toolpath template in VCarve. For this example we use a simple cabinet created in PolyBoard that we optimized via OptiNest and transferred into VCarve for cutting. Let's see how we do this. We loaded the optimized OptiNest file into VCarve. On the left side in the Layer tab you will find all the different layers transferred from PolyBoard with the corresponding variables that indicates setting parameters to be used during the creation of the different toolpath operations. On the right side you can find the toolpath operations. Let's start with the drilling operation. Click on the drilling toolpath icon. On the left side in the Layers tab you can read VDrill D5 P18, which translates to a diameter of 5 mm and a penetration of 18 mm, which is in fact a through drilling for an 18 mm panel. Fill in the cut depth value to 18.1 mm as you drill through the material. Select your tool from your tool database by clicking on Select in the tool section. Select tool number 2, which is a 5 mm drill, and click on Select to confirm. You can skip the next features as the pack drilling or drill and click on the selector icon. Here you are going to select which layer you will allocate to the drilling operation. Make sure you tick close vectors to activate the appropriate layers. Select now the VDrill layer in the right column and deselect any other possible selected layer. Very important in order to create a toolpath template is that you now select Associate with Toolpath and click on Close. You will see that all elements in relation to that specific layer has been selected on your sheet. Assign a name for this operation as, for example, drill underscore D5 underscore P18.1 underscore T2 and click on Calculate. You will get a warning as you will cut through the material, which here is normal, but due to security, the software warns always when you cut through the material. Click OK. The 3D view gets activated and shows you the calculated toolpath on the sheet so that you can eventually preview your first toolpath operation. Click on Close for now and switch back to the 2D screen. Let's perform the next operation, which will be the groove. Click on the pocket toolpath icon. Set the cut depth according to the value in the groove layer, in this case 10.5 mm. Select the corresponding tool according to the required width in the layer. Tool number 12, which is an 8 mm end mill, is perfect for this. Set if needed your passes, cut direction, ramp plunge and pocket allowance. Again, click on the selector button, select the groove layer and deselect any other selected layer if needed. Select Associate with Toolpath and click on Close. Name the toolpath operation as, for example, groove underscore P10.5 underscore T12 and click on Calculate. You will see now both created toolpaths on the 3D view. Switch back to the 2D view and click Close. Let's make the final operation, which is a profile operation, or cut out of the parts. Click on the Profile toolpath icon. Set your cut depth to 18.1 mm and use tool 13, which is a 12 mm end mill. Set your additional parameter as machine vector on outside right. We skip the other parameters and click on the selector button. Select the outline layer and click on Associate Toolpath. Click Close. All outlines are now selected. Name the operation Profile underscore P18.1 underscore T13 and click Calculate. You get again the through cut warning. Click on OK. All the toolpaths are now created and visible on the 3D. In the top right corner you can orientate the panel in the perspective view if you like before processing the simulation. Make sure all toolpaths are selected. Set the simulation speed to your preferred setting and click on Preview Visible Toolpaths. The toolpaths are now processed in order of the toolpath list. After the process is done, click on Close and switch to the 2D view. Let's now save this operation as a toolpath template. Make sure all toolpaths are selected and click on the icon Save All Visible Toolpaths as a template. Let's call it Test and click on Save. Right-click on the selected toolpaths and choose Delete All. We are now going to import our newly made template. Click on the Load Toolpath Template icon and select our test template. Our saved operations are now loaded and we click on the Recalculate All Toolpath button. The process starts and we get again the through-cut warning during the process. Once done, you get the message All toolpaths successfully recalculated. Click OK. Click on the Preview toolpath icon. Click on Reset Preview if needed, and click again on the Preview Visible toolpath icon. The process starts again. As you can see, creating a toolpath template speeds up the process considerably, and in combination with PolyBoard that delivers clear and consistent layers, the production flow is a smooth and efficient process from design to manufacturing. Thanks for watching this video.